Did you ever think about what it would take to build a home on Mars? It's not as simple as just packing your bags and boarding a rocket. The red planet, as exciting as it is, presents a whole array of challenges. For example, Mars has a thin atmosphere, extreme temperature fluctuations ranging from -60 to around 20 degrees Celsius, and it's covered in regolith, a powdery material that might just be the answer to our construction woes. Imagine using the very soil of Mars to create a sturdy, livable habitat, all thanks to state-of-the-art 3D printing technology. This isn't just a dream. It's happening now, and we're going to explore exactly how. So, what's the big deal about 3D printing when it comes to building on Mars? Well, 3D printing, also known as additive manufacturing, allows us to create complex structures by adding materials layer by layer. This means we can utilize local Martian resources, like regolith, to manufacture our habitats right on site. No need for expensive and heavy materials shipped from Earth. Think about that for a moment. By using almost 100% local materials, we can significantly reduce costs and improve sustainability for future colonists. It's revolutionary and might just be how we build our first cities on Mars. NASA has been at the forefront of research and development when it comes to establishing a human presence on Mars. They've initiated several projects to explore 3D printed habitats, including the ambitious 3D Printed Habitat Challenge. What's exciting about this challenge is that it invited architects and engineers from around the globe to showcase their ideas for Martian living spaces. The result? Some incredibly innovative designs that not only consider the structural integrity needed to withstand Martian weather, think harsh temperatures and radiation, but also how these habitats can provide safety and comfort for future inhabitants. NASA's winners have proposed concepts using inflatable modules mixed with 3D printed materials that serve as insulation against the extreme Martian climate. Now, let's talk about the role of robotics and artificial intelligence in this venture. Given the challenging conditions on Mars, where traditional human construction is impractical, it's likely that automation will take center stage. Imagine robotic 3D printers that can go to work as soon as a lander touches down, building habitats before humans even arrive. These autonomous drones can operate around the clock, creating everything from research labs to agricultural facilities, all while using local resources. That's AI and robotics doing what they do best, taking on dangers that humans can't, ensuring safety, efficiency, and speed on the Martian surface. Of course, there are hurdles to overcome. Mars has less than 1% of the atmospheric density that we experience here on Earth, and it's bombarded by cosmic rays that pose serious threats to both humans and materials. This means that any habitat design will need to be robust, possibly with double-layered walls or even underground structures to shield against radiation. Plus, consider the wide range of temperatures that materials must endure without cracking. This calls for materials that can expand and contract as they heat up and cool down, something researchers are diligently working on. You see, these challenges, while daunting, fuel innovation. Each obstacle brings with it a new opportunity to test technology and advance our understanding of living in space. Here's the exciting part. 3D printing is inherently scalable. Once the first habitats are established, inhabitants can leverage 3D printing to create additional structures as the population grows. We could see the emergence of entire towns on Mars. This matches perfectly with our long-term goals for Mars, where sustainability becomes key. With the right technology, we could build on Mars sustainably, pushing the boundaries of space exploration and eventual colonization. As we look to the future, the idea of terraforming Mars, transforming it into a planet that can sustain life, might one day not seem so far-fetched. While current technologies are still nascent, they offer a vital stepping stone to reaching that ambitious goal. 3D printed habitats are not merely an aspect of science fiction. They represent a real, actionable plan to prepare for human life on Mars. It is through these initiatives and ideas that we extend our dreams of exploration and habitation beyond the boundaries of Earth. Your feedback and support are crucial to this channel's growth. We're committed to improving the quality of our content, and your insights help shape that journey. If you have suggestions or topics you'd like us to cover in future videos, please drop them in the comments. We want to create a community where we can share and inspire one another about the wonders of technology and its impact on our lives, on Earth and in space. So let's keep this conversation going. Remember to hit that subscribe button and join us for more exciting explorations into the world of AI and beyond.